G'day everybody, this is the monthly meeting of the Access Express group in Australia, and today we're going to have a bit of a deep dive into database relationships. Crystal's going to give us a really thorough going over with the relationships in Access, and then I'm going to have a bit of a look at how we can pull all the information we may want out of a SQL Server database to inspect the relationships. So at this point, I'm handing over to Crystal.
Thank you, Kent. Welcome, everybody. And as Kent said, today we're going to talk about relationships, how they're different in Access and SQL Server and how they're the same. I will be doing the Access part. Kent will be doing the SQL Server part and also some with Access. And so my first is I'm going to talk about the relationships in Access, and we can look at a relationship diagram, see how our tables relate. Relationship is one line if it's on one field, and down there in the lower right-hand corner, you see a double line because it's a composite key on a relationship. This is a great way to visually see the relationships, but what about when you want a list of relationships? So we can write an SQL statement, and I'll show you how this works in Access. And Adrian has put a link in the chat where you can download the database that I'll be demonstrating. Now, in the SQL statement, it's getting information from the MSys relationships table. And it's also using a VBA function to turn the grbit, which I'll show you in just a minute, which is just a bunch of numbers or just a zero, into text. And here's what a datasheet view of the relationships would look like, information that you can pull out of the MSys relationships table. And I've also made a menu just to make it kind of easy to get to these different things. And here is my Access database. And if I click on the all relationships, what this is going to do is either create or use a query with this name up here. I tried to make it different so you wouldn't have a query with that name in your database. And here we have the parent table, the child table. Let me just make these a little wider. What the field name is in the parent table, what the field name is in the child table, which column number it is, and how many columns are in the relationship. Most of these relationships are just have one column in them because most of them are either like an auto number in the parent table to a long integer in the child table. But in the MSys relationships table, we also have this field called grbit, which isn't very helpful unless you write a function, and that's there's a module with a function in it to get the relationship type, which I've done here. I've written a function, and it's either in long form or you can tell the function that you just want an abbreviation, so it takes less space. And then we have a relationship name. So I'm just going to close this. I can also, with this interface, just pick a table, any table I want. I can do relationships just for that table. Let me pick a different one. You can toggle whether you want just the parent table relationships or just the child table relationships. You have to pick one of these. And then you just see the relationship where that table is the parent table. If I've specified I just want it to be the parent table part of the relationship. So here I have 7 relationships. If I also say I want it also to see the child table, where it's the child table, then here in this case I actually have 8 because I have a self join on that table to itself. Now let me just go to this address table for a minute. Over here on the right, I have some code that iterates through the indexes collection, and it tells you the fields in each index. And there's 6 indexes in the address table. Now, if I go to the table design of address and I look at the indexes window, I do not see 6 indexes. I only see 3 of them. Why is that? Well, when you make a relationship with referential integrity, Access creates a hidden index. So 3 of these indexes are hidden. 1, 2, 3. Now, it used to be in the distant past, I think, although now Access pretty much always creates a hidden index, one that you can't see when you make a relationship with referential integrity. So if we look at this relationships diagram, I'm just going to get rid of the navigation
So
page.
your code crystal is going to show us all of the indexes, including the hidden ones.
That's right. Yes, yes. So here we have some tables in here that aren't really well designed, and that's why they start with X test, because they're just test tables. They're not important. They're only in here just to show what a relationship looks like when you have a composite key. So in the parent table, I have a primary key on 2 fields instead of just 1. So in the child table, I have to have those same 2 fields over here, and then it makes this kind of a relationship with double lines. And if we go to the join properties of this, and these tables over here, like I said, in the lower right, they're not good tables. They're only to demonstrate how we can set a relationship on more than one field. So once we drag the line, then we can say, oh, we want more than one field in this relationship. So we could fill out the second row. And we could say, oh, we have even more. Well, now we have 3 fields. We could fill out something in the third row. So you can tell it how it relates. And when you enforce referential integrity, you can also cascade update related fields, which means if you change the information in the parent table, it'll automatically update that corresponding value in the child table. We could cascade delete related records. Most of the time I don't do that. Sometimes I'll turn on Cascade Delete just temporarily to get rid of a bunch of information, but then I generally don't have it on for the user interface. There might be occasions when I do that, but for the most part, no. In order for Access to make this relationship with referential integrity, and it doesn't really matter which one we pick, it has to create an index on the child side. The parent side already has to have a primary or a unique index in order to make a relationship with referential integrity. Well, unique is really the only qualification it has to have. A primary key also is unique. You can download this sample database that I'm showing you right here, and really it has one form and one module. So in the download section, I actually have 2 downloads. This just has the form and the module, just to make it easy for you to import this form and this module into any database that you're building. And this only is good for Access relationships. And then I'm also giving you this sample database that I have, just so if you want to play around with it, you can see how it works in this tool.
So if you're using Cascade Updates, you would use that if you've used, say, a natural key instead of a long integer ID?
That's right. Yeah, obviously, if you're doing a Cascade update, auto numbers can't be changed. So there'd be no reason to have a Cascade update when the primary field is an auto number because you cannot change it.
There's another cascade option that we can't see in the relationship diagram, which is a cascade to null.
Oh, yes, yes.
But that would only be applicable if the foreign key column in the child table allowed nulls, so it wasn't a required field.
Remember how I showed you everything is stored in that grbit numeric thing? This is the code that breaks it out into text. It's a bit mask. So we can test to see if it has referential integrity, and if it doesn't, then it's obviously a don't enforce is what is actually storing. And if dbRelationDontEnforce is not stored, it's obviously got referential integrity. So here we can check to see if it's unique, Cascade update, Cascade delete. Cascade to null, I've got that in here for you to check. Although you can't set Cascade to null in the user interface, you can set Cascade to null in code. So I'm glad you brought that up, Kent.
But only if that foreign key field allows nulls. Obviously. Well, it's not necessarily obvious, but that would be the case. So what's a bit mask?
If I want to test this to see if the relation is unique, I can use the and. I can say if this and that equals what I'm looking for, then I know that's set. And so I'm going to just add to the description either long or short, whatever the user wanted. If they wanted the abbreviated description or they want the long one. I have used this code for a long time. Alan Brown has this kind of code on his site, but I never understood how come I use that and I say if it's equal to what I'm looking for. I never understood how that and bit mask worked, and I got a little comment here at the top because now, ding, 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 the light came on because Adrian explained it to me.
All right. Well, Adrian can explain that after your presentation. Well, after mine, we can come back and Adrian can explain about how that bitmap works.
Right, because he's probably going to have to share his screen in order to properly show us.
Oh, well, at this point, just a quick explanation would be good. And in a future presentation, I'll get him to give a thorough going over on it.
Okay. And I was going to sing a little song here.
Time for coffee.
I'm not sure. Yeah, go get coffee. The thrills do abide with relationship. How do they work is rather queer. The index you see with the unique key is just half of what you need. On the other side, behind the scenes, Access makes a hidden tree. And the purpose of this little ditty is just to kind of hammer away with you that when you have a relationship with referential integrity, you have to have an index on both sides of the relationship to make that relationship work in Access. Now, it's different in SQL Server. And Kent is going to talk to us now about SQL Server relationships. So, Kent, take it away.
All right. Let me just pull up my SQL Server Management Studio and throw it over there. Now, SQL Server works a little bit differently to Access in a couple of ways. As we just mentioned, Access has that bit mask column for the cascading options, whereas SQL Server actually has a separate column for the Cascade delete and the Cascade update options. In SQL Server, we have relationships and we have indexes, obviously. In SQL Server, when you create a primary key, SQL Server automatically creates you an index on that column or columns in that table with the same name as the primary key constraint. However, unlike Access, which will create indexes for your foreign keys, in SQL Server, you have to actually create those indexes yourself. Now, the important thing to understand here is that a foreign key is what you use to join tables and often to search for things and what have you. And if you don't have an index, it's not going to be particularly quick. So it is worthwhile putting the indexes on all of your foreign keys. And that's the philosophy I subscribe to. So even though in SQL Server you don't have to have the indexes, it's a pretty good idea to have them. When we start digging into the system views in SQL Server, as opposed to the MSys tables in Access, we have these system views, things like this one here, sys.tables, which gives us a list of all our tables. We've got default constraints. So we've got system tables, we've got columns, we've got foreign keys, and we have foreign key columns. So with a foreign key, we have a parent table, and in SQL Server, we usually refer to that as the referenced table, and then we have the child table. And in SQL Server, in some places, they actually call that the parent table because that table is the parent of the foreign key. But in actual fact, it's not, because foreign keys belong to the database itself, not to particular tables. Indexes are in a collection that belongs to a table. Foreign keys are in a collection that belong to the database. And it's quite important to actually understand that. So here we've got our child table. We've got all the columns in our child table. Here we've got the parent table, which is the reference table. And here we've got all the columns in that parent table. And it's only really going to be the one that we're interested in, and that's the one, the primary key in this table that relates to the foreign key in the child table. So then we get a list of all our foreign keys. And again, the object ID in this case is referring to the foreign key ID, whereas previously in some of these others like sys.tables, the object ID refers to the table. This is where it gets a little bit tricky. To get all of the information we want about the foreign keys, we have to do some particularly interesting joins. One is to the foreign key, obviously, but then we actually have to use two joins to join on two columns, the column ID and the table ID in the child table, and the same in the parent table to get the details for the table name and the column name. In SQL Server, our columns are identified by this column ID, which is more or less its ordinal position. In any table, you will have columns numbered from 1 to whatever, but they are all going to be sequential. Unlike Access, where you can actually change the ordinal position of a column, in SQL Server you can't. And it's, I think, partly because it relies on that as its identification. Anyhow, so down here, by joining to our child table columns and our parent table columns and the foreign key constraint, we've got the foreign key ID, which comes from the foreign key tables system view. We've got the object ID for the child table, the object ID for the parent table. We've got a name of the foreign key, and you can see here where I've given them all nice names, where it starts with FK underscore. Then I would have, in this case, the product table underscore, and then the column name. We can see the table name, the column name, the child column name, the ordinal position of that FK field in the child table, And we can see if we go a little bit further over to the right, we've got the parent column name, we've got the reference column name. Now, they don't have to be the same, but generally they are. In some databases, developers can use a naming convention which, instead of using just ID, they'll use PK for the primary key and FK for the foreign key, so you can distinguish which field you're referring to in a query, whether it's the primary key or the foreign key. And sometimes that can be quite important. Then we come across to the delete action. Now, you only have two choices with delete action: no action or cascade. No action if you've got referential integrity enforced. If you've got child records, no action will prevent you from deleting the parent record, so you can't end up with orphans. So we've only got two options. We've got the cascade, which will delete all the children, or the no action will prevent you from deleting the parent. We do have another option that we're not seeing here, which is the cascade to null. So if the foreign key in the child table allows nulls, we can update the foreign key field to null in the child table. That would leave your child records, if the relationship wasn't mandatory, that would work. We actually have a fourth option in SQL Server that Access does not have, and that's cascade to default. Imagine I have a table, my invoice table, which has a customer ID column. And the customer ID column in my invoice table defaults to customer ID 1, which is cash customer. If I decide I want to delete all of the customers who've not made any purchases in the last 5 years, I can use that cascade to default to, when I delete all of those customers, the foreign key value in the invoice table gets updated to 1, which is cash customer. So I've lost all of the customer information, but the invoices are now just using the cash customer as their customer. So that's a nice little thing that SQL Server has that Access doesn't. We also have the other action, which is the update. Now, we spoke earlier about the cascading updates, where if you're using a natural key, you can use the cascade to update the child tables. That foreign key field in the child tables. Now, you notice here I'm not actually using any cascade updates. Now, why would you ever want to have cascading updates? Well, if we look at this particular relationship, and this is an Access database, Crystal showed us an example of a multiple relationship where we've actually used natural keys as the primary keys. So in TBL POP, POP's first name plus his last name forms a primary key. So you can only have one POP who has that first and last name. And we use that to join to the child table. And that is possible and it works. And if you change the father's first name or last name, that will automatically update the POP first name, POP last name in those tables there. Now, I'm not advocating this. This is not a good way to build a database. But there are some instances where I do this. I do use this. And an example would be where I have, in all my applications, I have a table, except this one, a list of all the back-end tables, and I have a list of all the columns that are in those tables. And I actually use the table name to join to the table with the columns. I'm just going to see if I can try and find one of those. So see here, I've actually got the table name is the primary key. Normally, I would use a table ID, which is the primary key, and I'd have a unique index on the table name. But in this particular instance, because I actually want to just be able to open the field table by itself and see what the table name is, I've been lazy and I've done it this way rather than try to create a join in the query. So that's an example where I have actually used both cascading updates and cascading deletes. So if I delete a table, all the columns belonging to that table will be deleted. If I change the table name, that table name will be changed for all of the columns that it's related to. When you're migrating to SQL Server, normally you're migrating one database from Access, say, into SQL Server. So one database into one database. I have projects where I'm trying to migrate dozens of Access databases into one SQL database. So you actually have to import the tables to get their new primary key ID, which then updates the child records with that new foreign key so that you can then import the child tables. All gets a little bit sporty, but so there are occasions where that can actually be quite useful. This view will be available for anyone to use. It is, as you can see here, a view. However, you can make that a stored procedure simply by changing that. And I would actually change the prefix. That can now create a stored procedure, which you can view using a pass-through query in the front end of your Access application. Having made it a stored procedure instead of a view, I can now put an order by clause on it, because you can't put an order by clause on a view, but you can on a stored procedure. So that's why that's there and commented out in case I want to change it to be a procedure instead of a view. So that's how we get all of this information about our foreign keys in SQL Server. And obviously I can use a pass-through query, or I can link to that view so that in my front-end application I can see all of the attributes of all the foreign keys in my database. We do have indexes, and similarly here, getting the indexes in SQL Server is a little bit easier. We just get the table, we get the columns, and then we get the indexes. And away we go, we've got a list of all the indexes.
That is a lot easier than with Access. In order to get the list of all the indexes for a particular table, you have to use DAO.
Yep. So there's some things that are easier in Access than SQL, and there's some things easier in SQL than Access. And this is one of those. Getting a list of all my primary keys. I can just I've cheated.
I was going to say, isn't there a difference between easy and I did this earlier?
Doing the Blue Peter thing, here's one I prepared earlier.
Pretty much, yeah, exactly. This is what you ran was something you prepared earlier.
Yeah. I mean, the index one, right, as you can see, it's not too difficult. We just join to the table and the column to get the names of the columns and the tables. We've got a list of indexes in there, and that's your index table. Now, clustered and non-clustered. In SQL Server, a clustered index is the primary key, And that's the index that the table is actually kind of stored in. So
Yes.
rather than having to do scans to find things.
It's a reverse of how you said it. The primary key is generally the clustered index rather than the clustered index is generally the primary key. But yes, it means that that's where the data itself is, that's the order the data itself is stored in.
Yep. Now, you
And
see,
you only have one clustered index in the table.
correct.
It would be difficult to store it by two different sort orders at the same time.
So yes, it can only have one clustered index. And in my applications, that is always the primary key, although it doesn't have to be the primary key. You can put the clustered index on another index, but I really don't know why you would.
You can leave it out altogether if you want to. If you're doing processing, clustered index, like processing one after the other, then clustered indexing works for you. But if you just want to find an individual, say you're looking people up and I want Crystal Long, I want to go through a quicker indexing thing than trying to find it in the data. So I would use a non-clustered index to find an individual record. Does that make sense?
Yep. You'll also notice that the way I name indexes, here you've got a PK. That index is actually created by SQL Server. I name the constraint with that name, and SQL Server automatically creates me an index with that name. However, where we've got things like FK, my T-SQL code creates that index, and I put an FK on the beginning to tell me that that's actually being used for a foreign key. Whereas just IX means it's not being used in a relationship. It's just an index used for making it faster to find things. But you don't have to use the FK, but your primary key indexes will have the same name as the constraint. And unlike Access, which gives you the name primary key without a space for every primary key, in SQL Server, your indexes and your primary key constraints must be unique for the entire database, not just for the table. So you can't call a primary key. So when you're migrating from Access to SQL Server, that's one of the things that has to change. You have to give individual unique names to the primary keys in each table.
You can call one of them primary key if you're bonkers.
Yeah. And you call the other one bonkers if you're a primary key.
Quite right.
Notice this column here, IX filtered. In Access, you can tell an index to ignore nulls. In SQL Server, you don't have an ignore null attribute for an index. What you can do is put a filter on it, which is kind of a where clause on the index that says, okay, I want this column and this column combined to be unique, where the second column is not null. So if one of the columns is null, it doesn't matter. You can have like duplicates of one column and a null, like one value and a null. You can have multiples of those. So you can actually have a little bit more control of how you filter rather than just saying ignore nulls. Do I have any examples in here? No, I won't have in this one. Yeah, so you can have an index that has multiple columns the same way as you can have a foreign key that has multiple columns. And if you're making a foreign key that includes multiple columns, it's also a good idea to have an index that has those same columns. All right, so here's my primary keys. We've got a data type, which is int, or it could be big int if you wanted to. Column identity. Does anyone know what that means?
Is it an identity column, unique?
Nope, that means it's an auto key.
Auto number. Yeah, auto number is what I was trying to, yeah.
All right, so you can see in some that I don't have, like, for example, a status table where I would generally create a table that has statuses from 0 through to 100, 100 meaning complete. In fact, I actually usually have 110 meaning cancelled, but from 0 through to 100 means, oh, okay, I've placed an order, I've received an order, I've got delivery, I've got the invoice, and it's all checked off and it's okie dokie and it's now 100. So I'm not using auto numbers. I'm specifically putting gaps between each of those IDs. So if I have another nuanced status that I need to put somewhere in between, I can without having to change all the existing numbering. But otherwise, mostly we have auto numbers, certainly on transaction tables. Now, to my mind, there are two main types of tables in databases. There are entity tables and there are transaction tables. So an entity table would be something like customer. A transaction table would be something like invoice. Now, as a general rule, and as we know, rules are known to be broken, entity tables you can edit. Transaction tables, once written, they should be immutable. Now, for example, with a bank transaction, if you make a bank transaction, you can't ask the bank to go back and change it. You can have them make an adjustment transaction, but you can't change the original transaction. So as a general rule, right, a transaction is something that happens once, and once it's committed, you shouldn't be able to go back and change it. There are some business cases where you may want to be able to, but as a general rule, that's the case. Whereas with an entity table, what I tend to do is I have an audit table on that entity table where any changes are recorded, but you can actually make changes. But this is getting a bit off topic. So now we know how we can get all of our foreign key information out of an Access database and a SQL Server database. And we've seen the nuances between the two and the things that you may need to address when you're moving from an Access database to a SQL Server database. And we can use these sort of tools like crystals and this system view that I've done to be able to compare and make sure you've got everything right. And it's a good time when you're doing that migration to check to make sure everything looks right and to fix up any relationships that aren't quite right, where you may have had missed relationships that you require to keep your data integrity.
I have a question about transaction tables. So you used invoice as an example. Well, and you said once it's committed. So does that mean you can create an invoice, you can create invoice items, but you have not committed it yet? Or is it committed as soon as you create the record?
That is actually a very good question. In some accounting applications, like trying to do battle with Xero, for example, where they have invoice records that have all sorts of statuses and they can be voided, they can be changed, and it's an absolute nightmare to deal with. What I'm talking about with committed is when you hit the save button and that's created. Now, in SQL Server, you don't get the ID of that record until after the update. Access will give you the auto number before, but SQL Server doesn't give it till you actually commit. Once you've committed a transaction, like a bank transaction, that's it. You know, you can't be halfway through doing a withdrawal of money. It's got to be one transaction. Once it's committed, it's committed. That is the ideal. And if you're talking about financial transactions, that's the way it should happen. If you're a bit wobbly with your business processes and you want to be able to mess with data, then yeah, okay, you can allow editing of transactions, but you've broken your audit trail. So if you're going to allow the editing of transactions, then you need to actually have an audit table on your transaction table, which kind of defeats the purpose. But an invoice, imagine you've got a main form and you've got a sub form. The main form is the invoice. The sub form are the items on the invoice. So you create the invoice on the main form, then you add all the items on the sub form. Now, at this point, as soon as you move to the sub form, that parent record is saved. But once you've finished entering all of the items on that sub form, there should be some mechanism to say, okay, we've now committed this invoice and we've printed it and we've now written it in stone.
There's obviously the concept of a SQL Server transaction, which I think you could encapsulate the whole process within a transaction if you designed it that way.
Well, that's ideal. And if you're doing it all with code, where on your access form, you create an invoice and then you create all the stuff down the bottom. And then in the background, you actually have a proper code transaction that's got like a begin and a commit, where you take all that data and actually put it in the real invoice table rather than what you've got in the form, which is just a temporary invoice table.
I'm thinking rather that you would have a SQL Server transaction, that you, however you create your data, you start a transaction beforehand, and then when you're happy with it, you commit it. It would create items. It would give you the primary key on the fly. But if you abort that transaction, then all of that would be cancelled. Well, rollback would be cancelling a transaction, yes.
On No Longer Set, Mike has an example of what he calls his B method, where when he tests a query in Management Studio, he'll begin a transaction, he'll run the queries that he's trying to test, he'll look at the result, and if he doesn't like it, then he does a rollback.
Yeah.
Right?
So
so you can do multiple goes at it without affecting the original data by wrapping in a transaction and doing a rollback. Now, I tend to do all that stuff in a test environment before I run it in the production environment. But even in the test environment, where you don't want to have to keep restoring it from your backup to run it again, that VBA method is actually really quite useful.
Indeed.
VBA has transactions, as does SQL Server.
Not sure you could say it's VBA that has a transaction. DAO supports transactions, so does SQL Server.
In VBA, you set your workspace, and the workspace owns the transaction. So you can start the transaction in the workspace, do whatever you want with VBA, and then get to the end and decide whether you want to commit it or roll it back. Obviously, if you end up down in the error section, you might want to roll the whole thing back. The purpose of it is, in the case of a bank transaction where you're moving money from one account to the other, there are actually two transactions there. One's taking the money out of this account and the other's putting the money into that account. And you want to wrap that in a transaction. So if either one of those fails, they both roll back.
I want to bridge off into something you were talking about earlier, if you don't mind. Are we done with this, or can we put it on pause?
Yep, go on.
Okay, so earlier you were talking about the fact that Access automatically creates an index on the foreign key in a relationship. SQL Server does not. Do you know why that is the case? And more importantly, why does SQL Server Migration Assistant not move that index, which Crystal pointed out is hidden in Access? Why does SQL Server Migration Assistant not automatically pick up that index and migrate it?
Well, the Migration Assistant hasn't been modified to do that. Now, there's a lot of things that the Migration Assistant now does that it didn't used to. It's getting better all the time. I still don't use it. But
so is that an oversight or just
it's an oversight.
Well, I think also, George, Access needs those indexes to make a relationship with referential integrity work. SQL Server doesn't hijack indexes like that.
SQL Server assumes that you've got database admins who are designing this and it doesn't get in the way, whereas in Access it doesn't assume that you've got people who are competent to understand how databases work at the fundamental level, so it does lots more for you.
No, that's a good explanation.
So yeah, the Migration Assistant has improved over the years, but it's still not perfect. And as I mentioned before, when you've got to migrate more than one database into one database, it just isn't going to do it for you.
Yep.
I like the concept of with a migration, you want to be able to have the whole thing repeatable. For foreign keys, the rule is both sides of the relationship have to be the same data type. And if they're like text, for example, they have to be the same length. So you can't join on a varchar max, a memo field, for example. You can join on a text field. You can even join on a date field, but that can get a bit icky if you don't have exactly the same precision of your dates. But if it's, say, for example, it's just the date value, then yes, you could. But generally we use a long integer or a big int for our joins. And in some cases where we're talking about using cascading updates, we're using text.
And also, I think on migrating, you want to be able to control the data type because some migration tools don't do that very well.
Yeah, well, so what I do is I create the schema. So I've got all of the database structure and I can fix anything that was wrong and get it all perfect before I migrate the data. And then I'll get the data, I'll migrate that, test it all, see if it works, empty the database out again, and just keep doing that until I know that come the day, I can hit the button and all the data will go in and I won't have any orphans and I won't have any errors and it'll all just work. One of the problems I see with the Migration Assistant is it takes a crappy database and shoves it into a crappy database.
Yeah.
I like to actually have a nice, shiny new SQL Server database that's got all the right foreign keys and all the right constraints and everything's just right, and then move the data. And the way you move data from one database into the SQL database, so from Access to SQL Server, ideally you want to use an insert query. Now, the problem with an insert query is that if one record fails, the whole query fails. So my methodology is, if that happens, I then use code that calls that same query, one record at a time, and bungs them in until I hit the one that causes the problem. And then I can fix the problem, and then I can run the whole query. But I'm just iterating through every record and using the same query, so you should get the same result when you do a bulk insert. There's strategies, but the important thing is that you get your new database right before you start trying to stuff rubbish into it. If you've got problems with your data, it's best to actually fix the data in the source. So if you've got orphans, for example, you fix it in the source rather than trying to fix it during the migration. So if that means populating the foreign keys with a legitimate referenced value, right? or if it means you just want to delete all the orphans, fine, but you fix the data in the source so that come the day of the migration, it'll all just go in. That's my philosophy. But,
Yeah,
you know,
it's good. I agree
yeah,
with
but a lot of people just want to, damn the torpedoes and shove it all in and worry about the issues later.
I have a story about why that's a really bad idea, involving lots of free maintenance work.
The migration
that.
is
Things that could crash.
to fix.
Sorry, carry on.
Yeah, so the migration is the ideal time to fix all the problems and have constraints in the destination database that prevent bad data and fix the bad data in the source so that it all comes together nicely.
There is another approach, Kent, which may be required if you have data which is bad, but only in the new version. So it could be quite correct where it stands, but when it gets moved, it doesn't work. So,
well, a good example would be dates that Access will deal with, but SQL Server won't.
Whatever the thing is, what you would then do is have a database, possibly in SQL Server, which is works as an intermediary. So you get your data into the intermediary, then do any fixes, and then have a separate, very similar set of processes which take it from the intermediary into the live.
Yeah, well, the reason that won't work is because you want the migration to happen in an instant. Once you've got all the migration designed and tested and working, you've got people still doing in production until when you want to do the exact, so tonight, as soon as we close the doors, we're going to do the migration, and in the morning, we're running with a different back end. Different
that would work.
Yeah. So it's all got to be done so that it's all can happen instantaneous. And while you're working on it, people are still working in production. And hopefully you've fixed the things that were creating the data. And it's only when you can get to the point where you can do a migration in a heartbeat without any errors that you're ready to go with the migration. Often one of the major issues you come across with migrating to SQL Server is that Access is very tolerant of dates that SQL Server isn't. And that's one of the major things.
Another big problem is if they didn't design their relationships with referential integrity, I have seen so many Access databases that just have lines. They think those are real relationships, but they're not unless you enforce referential integrity. And then Access has the default value of all numeric fields back to 0. I mean, it was 0, then for a while they made it null, and now it's back to 0. And people just don't realize they need to knock that out for a foreign key field. They don't want to have
why isn't that an option? Why is that not an option? Because if it's foreign key, why would you want it to default to 0?
That's where you really have to have somebody that enforces referential integrity and understands those foreign keys need to not have a default value unless that's actually the default value that you want. Maybe sometimes you do want 0 to be the default value of a foreign key. I occasionally do.
Imagine you've got a bunch of stuff with 0 as the foreign key. That allows you to identify and work on those items that you know a problem, but you don't know what the solution is immediately. But it flags it and it doesn't delete them, so you can't it.
So would leaving it null.
Better would just be to have an update query
Zero
that goes
null
and changes all those zeros to null.
Imagine the scenario I talked about before where you've got the customer ID in the invoice table. Now, if you made the cash customer 0, right, which I think you can do by appending into a table even though it's got an auto number on it, you can append an ID of 0. The problem I have with using 0 is that if you're using a data class, for example, and in a data class, you're storing all the values in variables and you're not using variant variables. So the ID of a particular record in the data class is being stored as a long integer. If the value is in the table is null, then you actually stick a 0 into that long integer variable in the data class. So the 0 equates with null. So when you're loading the data in from the table, if it's null, you get a 0, you use an NZ. If you're putting the data back into the table, then...
You're saying there's a situation where it can't tell the difference between 0 and null. Surely that's the outlier there, that's the problem, rather than having zeros and nulls. The system can store zeros and nulls. You're saying that one particular part of it is incapable of differentiating between the two. That's not going to be the only time it's used, though, surely.
I think the real reason that Access has a default set to 0, Crystal's already put her finger on it, is there are a lot of crappy databases out there with lines drawn, and they would all fall over if suddenly Access changed its behavior. And,
they changed that default to 0, and I didn't notice for years because I never create tables or columns in Design View. I always use code to do it.
Yeah. But I think it's like many other features in Access. They're there for the benefit of the citizen developer.
There's an assumption, isn't there, that they're not going to assume that you know databases well enough to handle this yourself. They're not saying, if you do, we're going to bugger it up so badly you can't do anything about it and we're not going to let you have control, because clever people can get around it anyway. But in SQL Server, they definitely do make the assumption. If you're playing with SQL Server and you don't know what you're doing, well, then you're on your own, pal. And that's a reasonable assumption.
Yeah.
You expect there to be grown-ups in the room when you're dealing with SQL Server. And if that leaves you, like it has done me in the past, a little bit short of expertise, then you have to go off and find it out.
Just trying to think of something else in here that's of interesting.
Earlier you wanted to look at bit fields.
This is exactly why I want you, Adrian, to give us these little lessons, but I want you to start off simple and work our way up.
What I think we need to look at is a big, massive, great big binary field, and we want 2 examples where a single bit is set. Most of them will be powers of 2. That means they're a single bit. In the same way that a power of 10 is always a 1 with X number of zeros, okay, in decimal. So your PN attribute and dbRelationDeleteCascade equals dbRelationDeleteCascade, then you're better off looking at that in the binary than you are me trying to explain the whole concept of AND. Ken, if you wouldn't mind going back to your immediate pane, show me what dbRelationDeleteCascade is, if you wouldn't mind. It's going to be a number that's a power of 2, but I don't know exactly. Ken, are you able to show me the value of that? 4096, that's a power of 2. Okay, now if we take a number, I want to take another number, which is, we have a number 4353. I want you to say, question mark in front of the 4096. Could you type in 4353 space AND? So in this case, we have a situation where 4353 is your PN attribute. Okay, dbRelationDeleteCascade. We could change. No, you don't need to change that, but you can change 4096 to dbRelationDeleteCascade if you want.
What's the 4353?
That is a number I've just created in my head. Well,
Oh.
I did it. For our purposes, it represents PN attribute. So I want a situation here where the PN attribute is ANDed. So you take the AND process and you get the two numbers together, and the result is 4096. Because what you're saying is, let's AND these two and see if the dbRelationDeletCascade is included as one of the bits in the 4353. You can't show binary, but you can say hex. So do a separate line if you can. Do hex, so the hex function, open 4353, close semicolon, hex dbRelationDeletCascade, close. If you hit OK on that, I should have put a space in between. Right. Go and put a space in before the rightmost one on that result.
The rightmost one there.
Yep, that's the one. So 4353, we've got actually 3 bits set there. On the left-hand side, we've got 1101. On the right-hand side, we've got 1000. We can pretend to a certain extent that we're dealing with binary here, although it's not. The one on the right is saying that's the only bit that I want to keep from the original. Okay? If you were to AND them together, if you put the 1000 underneath the 1101, so go on the following line and just type in 1000. Right. If you look at every single position there and say, which position has a 1 in both positions, then you'll end up with 1000, yes? All happy with that?
Where are we going with this? Sorry.
Well, you've got two numbers, one above the other. One represents 4353, but in hexadecimal, and the other represents dbRelationDeletCascade in hex. Okay. Now, when we AND the two numbers together, what we expect to see is only the bits left which are in both the top one and the bottom one, because that's what happens when you do AND.
Oh, okay.
Do bear in mind that you're treating them as decimal. If you want to see what happens, go to the question mark and then say hex, capital H preferably, open parenthesis.
What is better?
Proper name. Right, okay. Now, after the open parenthesis, where you are there, take ampersand H, right, and then go to the closing parenthesis, get rid of it.
What there?
Get rid of that close, yep, and then go to the beginning of that number and do another ampersand H.
There?
Yep.
Someone got to type there.
Now you need an ampersand H.
Yeah.
Right, and then at the end, do a closing parenthesis, and then you'll see the answer that we're looking at. What I was showing you was we understood it to be in hex, but if you ask VBA to understand that, you need to tell it that it's hex, and then you need to convert it back to hex afterwards, which is what we've done. So the hex at the beginning says, when you've got your result, show it in hex, and the ampersand H before a number says, don't treat this number as decimal, treat it as hexadecimal, which is why you've now got ampersand H 1101 and ampersand H 1000. These are two hex numbers. The calculation is done, and then the result is converted from decimal and shown in hexadecimal, which is why you see a 1000 there. Yeah?
Mm-hmm.
It's really interesting to see that you're using the hex function as well as putting ampersand H.
Any numbers that are like that will be treated as decimal unless you tell them otherwise. Sorry, Ken, what are you saying?
Unless you put the ampersand H in front of the number, so it's not a decimal.
Well, as I was going on to say, there are a number of different codes that you can use. Ampersand H is for hexadecimal. ampersand O is for octal. You don't need anything for decimal. But what that does, so putting an ampersand H in front of it says, instead of interpreting these numbers as 1,000, 1 times 10 to the power of 4, treat it as 1 times 16 to the power of 4. Your VBA is going to produce a result. That result is going to be in decimal. But we don't want to see it in decimal because that makes understanding what's going on much, much more difficult. So to display a value that it has in its memory and show it as hexadecimal, you have to use a hex function. That's not the same as telling VBA to interpret the string value that you've got of numbers as hexadecimal. That's when you use ampersand H. When you have a result that you want shown in hexadecimal digits rather than decimal ones, then you use the hex function. Be aware that queries don't deal with booleans in the same way that VBA does. So a boolean in a query will be converted to what it thinks of as a boolean value, which is -1 or 0. Whether a query would recognize the ampersand H, because that is specifically a VBA notation.
Ah,
Hex is a function that's available, so you should be able to get hex to work in a query. But whether ampersand H would is another matter.
but you could use a function to return that.
In November, dive into SQL Server migration planning with Kent. It's the third Friday in Australia, November 15th. In Brisbane, Queensland, the meeting starts at 11:30 a.m. AEST, which is GMT plus 10. Note, however, there's no daylight savings time in Queensland. It's always standard time. The meeting will be 1:30 a.m. in the UK on Friday. In the continental United States, the meeting is on Thursday, November 14th, 5:30 p.m. Pacific, 6:30 p.m. Mountain, 7:30 p.m. Central, 8:30 p.m. Eastern. Hope to see you. Join Kent as he deep dives into interesting topics for Access and SQL Server developers at Access Express Australia.